claim. I know that I proved you wrong, and I'm forcing you to face your claim head on. And I know this seems like injustice in the moment, but it's actually the right thing to do.
Is this an AA meeting?
What the fuck are you talking about? I've never
Are
been
you
to
guys
AA.
trying to convert me or something?
No,
It's a
I'm trying to
Globervention.
make you.
It's a Globervention.
Is this
Yeah, you guys are a bunch of perverts. I'm trying to help you out.
Globalvention?
Barry, did you say perverts?
I did. They're a bunch of
That's
perverts.
freaking awesome,
That's
dude.
amazing.
Well, you know, if people have problems, you do have to confront them once in a while and say, look, man, there's no curvature. You know it. I know it. We all know it. 100% of our experience is a level stationary Earth, and no one could deny that. Where's your globe? Fake space pictures? That's all you got? Come on, bro.
I mean, you're the one who's saying you're fake.
I just wish that I was good at playing Age of Empires and debating at the same time. I find that
But
it's difficult to do both.
is, you seem like you have so much fact about why the Earth is not flat. I mean, why the Earth is not round, but you have no fact or science
Hey,
behind
can you
it.
just address the video that I took the time to cite for you? Can you watch the video and
Wait,
say,
It's
you know
one
what,
video.
I was
Forget about
It's
wrong?
one
wait, hold
video.
on.
You think one
Forget
video is
about
going to...
Neil deGrasse Tyson. Forget about Neil deGrasse Tyson. What did I just say? 100% of your experience is proof of flat Earth. You
Not
experience a
really.
level stationary Earth every single day of your life. That's what you experience, not your interpretations of the sky or things you've been taught. Everybody experiences a level stationary Earth, and the most honest of Globers are at least able to admit that.
In order for that claim to be valid, right, it'd have to be that I can't mistake that for anything else. I know that I can
What do
mistake
you
that for
mean?
something else. So I
What
can't
do you
really
mean?
say
Mistake
that's
your...
right there.
Wait, hold on, wait. Mistake what?
Mistake that the ground is stationary and appears to be flat in my
You
field of
don't need to
vision.
mistake that. That's what you experience directly.
Again,
Why would
that
that be a
doesn't
mistake?
validate anything. That doesn't validate
Should I just
Doesn't
take
anything.
your word
it
for it?
doesn't necessarily but at least you have to admit that's what you experience, regardless if there's a reason that you don't experience it, because it's actually moving. You know, it's just a trick. Like your whole reality is the opposite of what it seems. If that's the case, then that's something to be explored. But until
Yeah,
further
yeah.
notice, we're all experiencing a stationary level of Earth. There's no reason to think otherwise, unless you have an interpretation or a story you've been fed.
No,
Yeah, yeah.
I think
What is
there's reason
self-evident?
to
Name
not,
one
no,
thing that's
hold on a
self-evident
second.
about the globe.
You didn't let me
What's one
finish. You didn't let me
self-evident
finish.
thing?
You didn't let me finish. I think there's
Go ahead.
reason to just withhold your judgment about the shape of the ground you're living on or the planet you're living on, whatever,
Well, yeah, but you're
right?
calling it a planet. That's an assumption, right?
Yeah, whatever they're
You're
calling
saying
it
it has.
that you'd agree with.
You're
Yeah,
also saying
I'm
it has a
saying it.
shape. You're also
I'm
saying it has
saying
a
you.
shape, which is another assumption. What if it doesn't have a shape?
What do you mean? Okay,
What
so
if it's
we
just
know
an infinite plane? We don't know how far down it goes. We don't know how far
a
out it goes.
plane.
All we can
I'd
know is
call a plane a
locally, we
shape.
all experience the stationary level Earth. All we can all know locally, we experience stationary level Earth. That's all we can all
Yeah,
really know.
locally. But again, I
Yeah,
think that still
yeah,
requires
locally.
extra investigation,
Okay,
regardless
yeah,
of
right.
whatever
I
I
agree
feel
with you.
initially.
I agree
It
with you.
doesn't matter.
You can. Well, cheers to you saying that you can withhold your decision about it, which is fine. I agree with that. It's not like we have to make some claim about what the whole thing is when we can't know that. I don't think flat Earth is about claiming the whole thing is one thing. That's the misconception that a lot of people, especially newcomers, get when they come into this conversation. They've been fed
No,
the idea that flat earthers are claiming that it's this disk in space or it's this a whole thing's flat, and we know because we know there's an ice wall and all these other assumptions. I don't agree with
yeah,
that.
but
Flat Earth is just
again,
realizing you're not on a spinning ball. That's all it really is.
the
Okay,
reason you guys,
I got you guys. I got you guys. You ready? I flew east. I did this. I flew east to the Middle East. I'm in the United States. Russia is west. I flew east to the Middle East, landed in the Middle East, stayed there for a while, got on a plane and flew east from the Middle East to Russia. Explain that to me.
Because that makes perfect sense.
Yeah, you flew east and you went east. Makes sense.
Have you ever
Not if
seen aviation maps?
Russia's
That's
behind
kind of
us.
where stuff is laid out on the
Behind?
Earth.
Behind.
I mean, Russia's
Oh,
a very
wow.
large area. Which city in Russia did you go to? Which city from the Middle East did you take off from? Those kind of matter.
Tel Aviv.
Tel Aviv, okay. Um, okay. And
Okay.
then which city did you go to? Moscow in Russia?
Not to Moscow.
Okay, so Tel Aviv to Moscow. Just pull up the map here.
Then I flew and then we got on a plane, flew east from Russia back to the United States.
That's fantastic.
And you
So, can you
have a
tell
problem with
me
that?
how much curvature you guys negotiated in those flights?
We did. We
Mic
did.
check,
We
mic check.
flew straight, and we flew
Wait,
straight
hold on.
east and hit all the points.
So wait, hold on. Forget about the curvature for a minute. Do you have any idea, like the basic concept? If the Earth is flat, North is in the middle, right? And you just go around in a circle the same way you would on a globe. If you're using a compass, it's gonna always go to north. And if you track that, and you go in one direction, you're gonna come around in a circle just like you would circle the ball. It's the same thing.
So where's north in the flat Earth? Like the center of the Earth?
Yeah,
The
it's
very
in the middle of
center.
the earth.
Wherever
So
there's magnetic north and then there's true north or whatever, and that's where the compasses always point, regardless if it's flat or ball.
Where's the center exactly? What is it
Well,
on
I
on
mean,
land or water?
well, no, the center would just be the declination of north, right? And that changes. Magnetic north changes all the time on a ball and on a flat Earth. There's nothing about the flat Earth that doesn't have an equivalency as far as traveling or the coordinates or celestial navigation. It's all interchangeable. It's all exactly an
Well,
equivalent, except there is a problem with flying and a ball Earth because that's impossible. And I can tell you why. You can't fly over a spinning ball and treat it like it's stationary, bro. It's as simple as that. All pilots are trained to treat the Earth as stationary. And if it's a spinning
no,
ball, that's a totally different situation and it would not work.
no.
But
That,
whenever it's in
You
promise
don't
right
motion, it
there.
stays in
that kind of
motion,
thing.
right?
You can say no. You can say no, but it doesn't work, and I'll tell you why.
A lot of bullshit.
You don't have
Oh, you can
understanding
just say
physics.
bullshit. Oh yeah, physics. Physics explains it. You can explain it to me then, right?
Okay, so are you aware, are you familiar with frames of reference?
Of course. Yeah, there's two frames of
Okay.
reference. We have an inertial and a non-inertial reference frame when we're talking about planes flying over a spinning ball. Correct?
Mm-hmm.
Inertial and
Yeah.
non-inertial, right? Yeah. So
Okay,
there we
and we
go.
can
We're starting
take
off good. And
okay, so we can take
conservational
the
momentum
Earth.
is also a thing, right? Conservational momentum. Let's talk about that. Let's get that out of the way. All right. We got 500
Okay, what
mile per
about it?
hour conserved momentum, right? Let's say that the plane took off where this ball is spinning at 500 miles an hour because it's a smaller circle than at the equator, where it's 1,000 miles an hour. Can we agree on that?
Yeah, somewhere in that ballpark. It depends
Yeah.
on
So
where you're
let's just say
taking
you're
this.
at a latitude where the ground itself is spinning at 500 miles an hour, right? Now, with the concept of a helicopter, maybe you'll take off from that 500 mile per hour latitude. And a flat earther might have the misconception that the earth is going to spin below the helicopter just because the helicopter is in a separate reference frame, right? But that's not correct because the helicopter has conserved momentum. Can we agree on that?
Yep. Once it
Yeah. So
takes
the
off, it goes to the
helicopter,
same. Mhm.
right? Yeah. The helicopter got the conserved momentum from being on the earth, right?
Yeah, makes sense.
Yeah. Yeah. It was spinning with the earth. And because it was on the earth, it has that 500 miles per hour conserved momentum. So it goes straight up in the air and it's just spinning with the earth still, right? We agree on
Yeah,
that? Yeah. So
absolutely.
there's no reason to think that the earth would just spin, even though it is independently in a separate reference frame. Let's just say the helicopter moves along perfectly in sync, right? Now it would have to be in perfect sync with the 500 mile per hour spin, right, to be able to land on that earth as if it's stationary. But we don't have to worry about that, right? Because the helicopter's going along exactly at 500 miles an hour. If it wasn't,
Well,
there'd be a
no.
problem. But good enough.
Helicopters don't
Good,
go
good.
500 miles an hour, and the Earth spins at 1,000 miles an hour.
Well, no, at
I
different
mean, it depends
latitudes,
on
it
your
spins
frame of
at different
reference,
rates.
but yeah.
No, no,
Well,
no,
yeah. I
no. It's
mean,
not about the frame of reference. Like, don't interrupt me. I'm trying to get to a point here. We're agreeing so far, okay? The 500 mile an hour comes from
I'm not.
the helicopter being at a certain latitude, right? Now, if it was at the equator, yeah, it'd be 1,000 miles an hour. But the circles get smaller as it goes to the poles, right? They say it's zero at the poles, which is a little silly, but let's just say it is. We go 500 mile an hour, like right in between. So, like, let's just say the helicopter took off and it's spinning perfectly in sync with the Earth. There's no problem. The helicopter can just treat the Earth as stationary, just like the pilot's taught to, right? And just land because it's already going 500 mile per hour with that conserved momentum eastward, right? It doesn't matter which way it's facing. It could go sideways. It could be backwards. In fact, it would be going backwards with the Earth because it was on the Earth, right? Good thing it was on the Earth at 500 miles an hour. Now, let's just say that that's the case, right? It has to be in sync. It has to be in perfect sync. Otherwise, the ground is going to be spinning at a little different rate than the helicopter when it tries to land. And the helicopter pilot is just taught to treat it as stationary, just like all jet plane pilots are as well, right? So they all just treat it as stationary. Now, let's just say that plane took off at a 500 mile per hour latitude and it's headed south, right? Now that plane is automatically spinning sideways at 500 miles an hour when it takes off because it was on the ground when it took off. It conserved that 500 mile per hour latitude momentum, right? So it has that eastward rotation. Now it's going sideways, even though the pilot's not aware of that. It's going sideways in perfect sync with the Earth when it takes off 500 miles an hour, right? Can we agree on that?
Sure, but I fail to see
Yeah.
the
Let's
issue
just say that we're going to go from there and not have any kind of like, what about this and what about that until we get to the point.
of
500
Allah.
miles an hour eastward, conserve momentum. The plane has that. I'll give it to you. Let's just say it has that. Let's just say it never even loses it, even though you would expect that it might lose it. And you would expect it would need more the higher it goes because it's a greater circle. But let's just forget about all that for now. When the plane flies to the helicopter to the equator where there is 1,000 mile an hour runway it needs to land on at a different airport, right? And it's going to treat that 1,000 mile an hour runway as stationary. Now we got a problem. It only had 500 miles per conserved momentum. Where does the extra 500 mile per hour conserved momentum come from? So the pilot can just treat that runway like it's moving at the same speed of the airport it took off from. How does it get twice the amount of acceleration sideways eastward when it's headed south? Where's that double the amount of conserved momentum come from? That's the $1 million question. How does the plane get twice as fast sideways so then the pilot can just treat the Earth as completely stationary, just like all pilots are trained to? Where's the double the amount of eastward rotation? Where's that tangential velocity come from? Can anyone name the mechanism that accelerates the plane perfectly twice as fast sideways so it can be in perfect sync with the runway at 1,000 miles an hour? Not just a little bit more, not just a little bit less. It has to be 1,000 miles an hour eastward, sideways, as it's landing, completely in sync with a 1,000 mile an hour runway, even though it only took off at the 500 mile per hour conserved momentum. There's a problem
Okay,
there because not only does it have to be in perfect sync, it has to continue
clarifying.
spinning eastward with the rotation of the Earth perfectly as it slows to a land in a perpendicular direction. Now, that's a big problem for the dull Earth because all pilots
Okay,
are taught to treat it as stationary, and it just doesn't work, boys. Unless you have a good
so
answer, go ahead.
clarifying question. So we're saying that the Earth is spinning perpendicular to the direction in which the plane is moving, upon
Correct.
landing. Okay,
Yeah.
and you're saying that once it touches the ground, right, there'd have to be a 500 additional miles per hour to keep the plane like balanced or whatnot to prevent it
Well,
maybe
not just
slowing down.
balance. It have to like be able to be in perfect sync sideways with the Earth because it's a different rate of spin at the equator than the airport it took off, which is only 500 miles an hour. And it doesn't get more momentum from being in the air because wind's going all directions. So it can't be a wind that accelerates it twice as fast. But whatever's making it go twice as fast sideways, right, has to continue doing that as it's landing in a perpendicular. There's no force, there's no mechanism. Now you can just have like a kinematic answer, like a kinematic mathematical idea that it just cancels out and it's automatically in sync because we want to think about it as like 15 degrees and it doesn't matter where it goes. But the problem is the literal claim is that the airport it took off from is only spinning at 500 miles an hour. And the airport it's going to land at is spinning at literally 1,000 miles an hour, twice as fast. That's the claim of the ball earth. There's no straw man. It's just what the ball earth says happened. And the best of the ballers say that the air makes it accelerate automatically somehow. Now you tell me how that makes sense. How does the air make the plane twice as fast sideways when there's no mechanism, and the air moving the plane would have to be a wind, and winds go in all directions, so it does not work.
I think I'm starting to get your. Okay. It might take me a little bit of time to think this one out.
Well, I could put some gifs that might help, like some visuals in the chat for you right now.
Yeah, I think sometimes flat earthers make bad arguments. I think that argument that he just said is bulletproof because there is no mechanism. There wouldn't be, even if the model was correct.
Yeah, we call it the silver bullet, Kenny and I. We're like, that's the silver bullet, because there is no answer for that one, and there has to be, because you're claiming that the airports are at different rates, and that's the ground speed at the equator, which is 1,000 miles, or about 1,000 miles an hour, depending on where the airport is.
What
But
does
it would
JA
have to
say?
accelerate. Now you hear, oh, you just he doesn't know what to say. He says that oh no, in fact I have a recording of me and him talking about this. He and I talking about this recently, and he was saying that there's like this like the molecules of air are spinning, and there's friction. And then he started like trying to like Avogadro's equation he brought out. Avogadro's. I looked that up, and it's about like the molecules of air, the density of air molecules, and I'm like, okay, so the air molecules and the wind that's going in the opposite direction, how does that set it off? And how is it, are these densely compact air molecules now perfectly overriding those air molecules of the wind going in the opposite direction to somehow make the plane sideways perfectly in sync? See, the best of the ballers know that they have to have an answer for this. They can't just hand wave it. They can't just say it works. They have to come up with some kind of explanation, and they all guess at it like there's like some answer that we don't already know. Like, I mean, if there was an answer to that, it would just be like, look it up. Here's the answer, and it works. But there isn't one to look up because it doesn't work. They just say that the pilot treats it as stationary. They don't say how that's possible with the different tangential velocities. You have a gradient of tangential velocities, and that fucks the whole thing up because we have a very testable method. We have a plane as a separate reference frame that would have to be accelerated twice as fast sideways when it lands. And there's no mechanism to do that. It just treats the Earth as stationary. It flies point to point. I mean, I didn't even get into the fact that it'd be twice as long for the air, or almost twice as long for the plane to even get there, because the destination's moving faster than the plane is when it takes off. So it would have to play catch up the whole time.
So I've known about this argument. I think I heard you say it a month or two ago, and I have been deliberately avoiding this argument so that you could make it and hear it for the first time, every person you come across, because it's your argument. I bet after a
We'll
while
go
I'm
back
going to
and
steal it from you and start
I wrote
using
it
it.
all out so anybody can make it, because it's a globe killer. It really
Yeah,
isn't. There's no answer to it.
yeah, but
And
I
it's
was
funny
letting
because
you work it
a
out
lot of
because that's how you test out
yeah,
an argument, work it out and get it good, right?
they don't have an answer. You can tell. I mean, if they had one, they'd already be talking, right? They don't.
Yeah, send it to me if you wrote it out. Direct message it to me
Yeah,
because
sure, yeah, no problem.
eventually I'm going to start using it.
I had the version I wrote out recently. I have a bunch of different versions of it because I was trying to explain it to people, even though it's like a really easy argument. It's nothing new. I didn't come up with it. Obviously, it's something we've been saying since 2015, right? It's just not. It hasn't. I just kind of put it in a context that just use the same wording
Yeah,
of
I
it.
think what
So
you did that
you
was
get it.
special is you went from north to south, so from Canada to Ecuador.
Yeah, basically. But the one I was going to say, the version I wrote out recently in full is now like, for like a more advanced version of it would be kind of like, okay, so let's just say there's also another plane coming from the airport at 1,000 miles an hour, and it's going to land at the airport that the 500 mile per hour plane took off from. and then they're going to like wave to each other, right? As they pass each other, they're just switching airports, right? And they're going to wave to each other in the air, and one of them's going to land going twice as slow, and one of them's going to land going twice as fast. So how is the air making one of them go twice as fast in one direction, and the other one going twice as fast or twice as slow in the other direction as they pass each other? Like, just like to wrap your mind around that one. Like the air doesn't do it anyway. It couldn't because the winds could be blowing them in every which way, and the pilots can just be aiming wherever they want. But if they're in a separate reference frame, there's got to be a deviation. And you hear the ballers say, "Oh, it's Coriolis. As Coriolis is just hidden in the winds." I even wrote a song about it. Hidden in the winds. Coriolis hidden in the winds. It's just like, what? So the winds would be so much stronger than this Coriolis force that we don't even have to worry about it. Oh, really? So at the same time, you're saying that the winds or Coriolis winds or whatever that is overpowering these winds and making it go twice as fast, perfectly sideways. What about the jet stream? What about when it goes into a jet stream and it starts going 500 miles per hour faster than the supposed spin of the Earth? Right now, it comes out of the jet stream. How's it going to land perfectly in sync with the Earth? It has to be perfectly in sync, like it's stationary, so perfect that the pilot can just assume it's stationary. Well, you got a challenge there, man. What the hell does that?
Against the wind.
Oh, Coriolis be hidden in the winds.
Yeah, that's a good one. That's definitely going in my repertoire.
It's something everyone can relate to because we've all been on planes. We never see the Earth moving in. I mean, they have planes, they have jets that go 1,000 miles an hour, right? Just fly
Yeah.
one of those fuckers and get out of sync with the Earth, right? Just fly it till it's out of sync and then put a camera out the window and show the Earth spinning independent. Show the Earth spinning left to right underneath the jet or whatever. You got those jets that have like 40,000 pounds of thrust resistance, can just hover in midair. put the camera out the window and show this spinning Earth. Go ahead, Glovers. Perfect opportunity to prove the Earth is spinning, right? Easy enough and provable.
And I'm back. What have we been talking about? I've been gone for about 30 minutes.
I'm sure you didn't hear any of it.
No, I was gone. I was on the phone with work.
Sure.
What's going
Yeah,
on?
okay. So
Yeah, we were
we've
just
gone over
talking
this
about the
before,
globe.
Platypus.
I was also
deafened.
deafened. I was also deafened for the entire time, in case you
Oh
didn't
no,
know.
that's okay. I mean, I could explain it to you. So if a plane flies from a point on where it's only spinning at 500 miles an hour, and it gets its conserved momentum from being on the Earth, when it takes off, that's why we see that helicopters, don't have the Earth spinning separately from underneath, right? Because it was on the Earth, so it's spinning with the Earth automatically. You agree that, right? That's the reason that the Earth doesn't spin independently of something that goes straight up in the air, right? Because it already conserved the momentum from being on the Earth, right? You understand that concept? Yeah.
Yes.
Yeah. Okay. So a lot of flat earthers sometimes will say, well, all you have to do is just jump up high enough and then wait for the Earth to spin below you and travel to France or whatever. That's not a good argument because you have this conserved momentum idea. But even if we let you beg the question with that 500 miles an hour, right? It only has 500 miles per hour conserved momentum. When it flies south and it goes to an airport that has a runway moving at 1,000 miles an hour, how's it going to treat that runway as stationary when it needs to be going twice as fast sideways?
It's because you, the plane, everyone on the plane, the atmosphere around the plane, and the airport runway are all moving with the Earth.
Yeah,
We're all moving.
That's a typical first answer, but then you have to explain how it goes. It gets accelerated twice as fast sideways. Perfect.
Why would it have to accelerate twice as fast?
Because it's 1,000 miles an hour at the equator, and it only took off with a conserved momentum of 500 miles an hour.
Yeah, how far did it have to travel to do that, and how long
It doesn't really matter. It doesn't matter, but let's just say 10 hours, and let's say it was in the air like 6 hours, 7 hours, 8 hours, whatever you want. Why would that matter?
Well, it does matter. You do have to account for that.
Okay.
It's called the Coriolis effect. You do.
Yeah, you would have to account for that, right? So the
Well,
pilot's taught to account for that.
Yeah, but the problem is an airplane is not a non-sentient object that gets launched from point A expecting to go to point B. It's under constant manipulation by the pilots operating it.
Yeah, the pilot is taught to treat the Earth like a spinning ball, right?
Yeah. You know why? You know why it doesn't matter? You know why it doesn't? You know why the pilot doesn't have to actually account for that? Because he's going to account for
exactly what I just told them. People say
because he has to account for so many other things.
So much less than the winds, right? It's so minimal compared to the winds, right? I was just talking about that.
It's not that it's less than the winds. It's not that it's less than the winds.
Ooh, what's not?
Wait, let's jot this out. Hold on. Let's think about this from point A to point Z, and this will also cover your stupid planes don't constantly dip down to account for the curvature argument. Okay.
I said nothing about that.
Okay, then we'll ignore it. I was gonna tie both of them together, but if you want to just do yours, then we'll just focus on yours.
No need to.
So if you're going to fly 1,500, let's say it's 1,500 miles, okay, from a point, and let's consider the worst case scenario. Let's say you're flying due south for the entire flight, okay, straight south. So after you go 1 mile, what's the change in speed?
It doesn't matter, dude.
Yeah, it does.
Oh, really? So you're saying the pilot's taught to account for that?
The pilot's taught to fly the plane.
Yeah,
they're taught to maintain altitude and maintain speed so that they have lift.
And wait, hold on. Let's just agree that they're taught to treat the Earth as stationary and level, right? Can we agree on that?
To treat it?
Yeah, they're taught to treat the Earth as stationary.
Another way of putting that is they're taught to ignore any of these external forces that you're talking about because they're negligible. Yes, they are taught to do that.
That would be a convenient thing if it was negligible. That'd be convenient, though. If it was negligible, that'd be really convenient. But regardless, we can agree that they're taught to treat the Earth as stationary. They're never taught to account for any spinning or any curvature, correct?
Because they don't have to, yes.
Yeah, because they don't have to, supposedly, in your mind, but they would have to when you really break it down, brother.
Prove to me that they would have to. Break it down for me.
All right. So how does it get accelerated twice as fast sideways when it's trying to land at 1,000-mile-an-hour runway, bro? What's the mechanism? What's the mechanism that accelerates the plane perfectly twice as fast sideways, regardless of winds, regardless of what the pilot does?
It's called the jets on the fucking plane, you idiot. That's what they use to accelerate.
Are the jets?
Come on, be nice. GE Platypus.
I'm trying to be nice. I'm trying to be nice.
Hold on, wait. You don't need to tell him to be nice because I'm not going to be nice. All right, because
I know new perspective.
He doesn't know what the fuck he's talking about. Are you saying that the jets are sentient now? Are these jets sentient, or is it the pilot that's sentient?
Are you fucking kidding me? The jets are under the direct control and influence of sentient beings.
Right. So the pilot's taught to treat the Earth as a spinning ball, and correct for this Coriolis you're talking about.
No, you just said specifically that the pilots aren't taught to do that. What pilots are taught to do is to maintain altitude and lift so that they don't fucking crash.
Okay, so then the plane does need to be going twice as fast sideways. Do you agree on that at least?
What do you mean twice as fast sideways? What does that have to do with it?
Do you realize that the pilot would be landing at a runway at an airport where the ground is now spinning at 1,000 miles an hour, whereas he took off from a place that was only 500 miles per hour because it was a smaller circle towards the poles?
You act like airplanes cross a magical barrier where all of a sudden and instantaneously the ground beneath them is moving 500 miles an hour faster than the point that they started at. No, dickhead. It happens gradually over the course of a several hours long flight. You're pretending that it's a claim. No, you're pretending that it's instantaneous.
Wait a minute. I've had this straw man before. Let me just deal with that first, because I'm not saying they're teleported, right? They can go. It could take 20 hours to get there. It doesn't matter how long it takes to get there. It has to account for that. There has to be a mechanism that you name that makes the plane perfectly in sync with 1,000-mile-an-hour runway when it only had 500 miles per hour conserved momentum. What's the mechanism that accelerates it perfectly twice as fast sideways so it can treat the Earth as stationary when it's landing?
Why would it be accelerating
Name it.
sideways? Why would it be
Well, it has
accelerating
to.
sideways?
It would have to.
Why?
Because the Earth is
To
moving at
account for
1,000
the
miles an
rotation of the
hour
Earth
No,
underneath
rather
that's
than
the
not any,
500.
no, that's not the answer to my question. My question is, why would they have to?
Be going
to
500
account for
miles
the
an hour
rotation.
slower
Because
than the runway it's
really
trying to
saying,
land
hold
on.
on. No, hold on. What you're trying to say without actually saying the words, which I would appreciate if you just
I'm not
did,
avoiding a
was
thing, dude.
no. You're not
I'm not
just
avoiding
saying it.
anything.
What you're trying to say is that it's ridiculous and impossible that they can do that.
No,
You're
I'm
trying to say
saying
it's
that it doesn't.
impossible.
No.
You're
What
phrasing it
I'm
as a
saying.
question. You're saying, well,
Well,
why
no.
don't they account for this? What you're actually trying to say is it's impossible for them to account for that.
No. You get me wrong. What I'm saying is it's impossible for a pilot to be trained to treat the Earth as stationary if it's actually a spinning ball, because you have a gradient of tangential velocities that would not match with its original conserved momentum, and there's no mechanism you can name that makes it perfectly in sync with a faster runway.
Okay, here's what I propose. So I'm going to say the Coriolis effect, but let me explain the specifics of it. So let's use our numbers, the 500 miles per hour and the 1,000 miles per hour, right? And that's the difference in the speed where they take off and the speed where they land, right? And let's say this is over a 10-hour flight. This would mean that over the course of this 10-hour flight, they'd have to adjust about 50 miles eastward.
Hello?
Hello.
Oh, can you guys hear me?
I think he's testing his mic.
Okay, let me just gather myself.
Well, somebody was cutting in. Platypus, do you have an answer for that last thing I just said? You need the plane to be moving twice as fast sideways for it to be in sync with the Earth, regardless of how long it takes, regardless of the sentient beings, regardless of anything that you've given so far. You have no mechanism that does that without the pilot's conscious intention to do so, regardless if it's incrementally or whatever. He has to account for that.
Hey,
There
do you know
has to
what
be
pilot?
a
Hey, hold on.
mechanism
Hey, hold on.
that does
No,
it.
hold on.
You
Hey,
can't
do
just
you know what
treat the Earth
pilots?
as
Hold on.
stationary and have it happen magically, dude.
Do you
have
know
no
what
answer for this
pilots?
yet.
Hold on. Yeah, I do. Yeah, I do. Do you know what pilots are in a constant state of doing while they're flying a plane?
Flying the plane. Oh yeah, adjusting for their path. Right now, you know that a pilot can get off course.
No,
The path doesn't solve
that's
this
not
for
what a
you.
pilot.
The
No,
ground
you're
path
wrong.
does not solve
That's
it
not.
for you.
You're wrong. That's not what a pilot's constantly doing.
The pilot can
No.
fly, and ever since planes were invented, pilots fly wherever they want, north and south, and land as if the Earth is stationary. Your ground path is not going to solve this for you, bro.
I didn't say anything about ground path.
Oh, that's what you weren't about to say, right? You were saying he tries to stay on course, right? You were going to say he's staying on course.
No,
right?
Don't put words in my mouth. That's not what I was going to say.
Okay, what were you going to say?
I was going to say two things. One, you're wrong about what pilots do, and two, what pilots actually do is maintain altitude and course. That's it.
Okay, so you added altitude. I said you were going to say course, and you said course, and then you added altitude.
No. Hold on. Altitude, I've been saying from the beginning. I said course just now. What I meant was lift.
Okay, what does that have to do with why is that? How does that solve your problem?
They're in a constant state. Listen.
Course doesn't help you.
Do pilots care about every little gust of wind that hits the plane? No. All they care is when. No, they don't. No, they don't. All they care about is when something happens to the plane that changes their altitude or their lift. That's it. All these little things that you like to pretend planes don't account for, they do account for while they're already accounting for everything else.
Dude, you act like I'm denying how planes fly. That's not the point.
No, and you also like to act like on your flat Earth, planes wouldn't constantly have to turn to the left or right, which you know they would have to do.
Never said that either. That's a straw man as well. Planes fly exactly how they're supposed to, right? No, planes fly exactly. There's no conspiracy here, bro. The pilot's taught to treat the Earth as stationary. And
planes
the Earth is stationary, so it works perfectly.
Excuse me. Planes don't fly how they're supposed to. pilots fly planes how they're supposed to. And there's a
Sure,
difference.
yeah, pilots fly the planes. Yeah, I agree with that. Pilots
Yes.
fly the planes how they're supposed to, and they're treating the Earth as stationary, which is how they're supposed to, because it's freaking stationary.
Then why would you add the operator of treat it as stationary?
Well, that's what
I don't know.
You would just say that it's stationary.
They have to, exactly. They have to say on the globe side, or the globe in general, has to say that the pilots treat it as stationary.
Why?
It's not actually stationary, but they treat it as stationary somehow. Like there's a difference, right? If they're treating it as stationary, it's freaking stationary, brother. There's no other way for it to work. There's a tangential gradient. You have no answer.
An object in motion stays in motion.
Yeah, 500 miles an hour. That's what it has, right? The conserved momentum is 500 miles an hour. It doesn't have 1,000. It needs twice as fast when it gets to the 1,000 mile an hour. Runway.
Somewhere between.
Just to clarify, you're saying that. Sorry, you can speak
go ahead.
first.
Nope, go ahead. Go ahead.
I was asking you perspective. You're saying that planes need to change their course because the Earth is orbiting?
No, that's totally not it.
Can I perspective. Hold on, perspective. Just hold on.
Let me reply to the guy that doesn't understand.
I want to explain it to him. I want to explain it to him. And then you can tell me. I want to make sure we're on the same page.
Are you going to steel man my argument? I'd love to hear that.
Steel man? What is a steel man?
Okay.
Steel man is when you actually acknowledge the person's argument they're trying to make before you start straw manning it.
I can acknowledge it without agreeing with it. What perspective is trying to point out is that when you fly north to south or south to north, there is a change in hold on.
Tangential velocity.
When you change
tangential velocity.
There's a change in tangential velocity because technically the speed at which you're rotating with the surface of the Earth changes the closer or further away you get from the equator. If you're at the equator, it's the highest, because it's the outer edge of the thing that's rotating. So you're covering a longer distance in the same amount of time because the Earth all rotates one turn every 24 hours. The closer you get to the poles, it's shorter, which means your am I mixing them up? It's the tangential velocity. The tangential velocity gets smaller the further you get from the equator.
Yeah. So if it takes off from a place that's only spinning at 500 miles an hour, we can let you beg the question and say it's conserving that momentum the whole flight. But it doesn't matter because it needs 1,000 miles an hour rotation eastward, perfectly in sync with the eastward runway that it's now treating as stationary when it gets there. And it has to be spinning in perfect eastward tangential velocity with the rotation of the Earth, so the pilot can just assume to treat the Earth as stationary when it's landing on a runway angled at whatever which way. The winds blow in all directions. So if the winds are affecting the plane's eastward rotation, which it would, but we don't even need to worry about that. But if you have strong western wind, you're not going to be accelerating sideways, and this would all have to happen without the pilots being even conscious of the fact that he's spinning with the Earth at 500 miles an hour when he takes off sideways, headed south, and that somehow when he gets there, he's going twice as fast sideways to keep up with the rotation of the Earth. So much so that he doesn't have to worry about it at all. He just flies as if it's stationary the whole time. Lands on the 1,000 mile an hour runway, just assuming that somehow his plane's automatically going sideways, tip to toe with this eastward rotation. And there's no mechanism to make that happen. And the pilot's not taught to account for it. So this dispels the ball completely, bro. We have a mechanism that we use all the time. Pilots land as if it's stationary. They fly from north to south and south to north, and don't ever worry about this difference in tangential velocity that they would have to account for. So it fucks the whole thing up when you really break it down.
Platypus, there's a term in aviation, and I've been Googling it, and I'm trying real hard to find it, but there's a term for pilots that constantly scan their gauges. They're checking their altimeter, their direction, their speed, all that. I forget what that term is, but they're constantly making corrections. Now,
I don't know if it's... Hold on. I don't know if it's the same for a submarine, but we always called those people scanners.
Yeah, that's what I thought of, scanning. scanning your gauges, whatever term. I was trying to use the right term, but the whole point is the longer the distance, the less correction required if what's his name was saying is true. That, the longer the distance, the
Well,
twice
there'd
the
be two
speed.
factors here. It would be the distance traveled weighed
Yes.
against the total change in latitude over the course of that distance.
Yes, so the longer the distance to the equator, the less correction required per minute or whatever convention you want to use. So I understand the argument. It's just that it's not like you get to the equator and shit's traveling immediately twice as fast. No, because you're constantly changing and making corrections over that distance. And
Yeah, but that's another straw man.
Yes.
That's what Globers
I'm not
tend to
straw
say.
manning.
Like, you're saying, well, it is if you're thinking that I'm saying it's going to all of a sudden be going faster
True.
when it gets to the equator.
Well, it completely.
that.
Hold on, real quick. Completely divorced from anything Perspective was saying for the past 15 minutes. What Oblivion just said is exactly how it works.
What do you mean?
Pilots are in a constant state of maintaining where their plane is going and how fast they're doing it, and at the altitude that they're doing it at.
Well, that's a very good point, and so you're saying then that there's a gauge that tells the pilot how fast the Earth is spinning below it, and it makes sure to check all the time that the plane is automatically somehow going to be correcting to be in this eastward rotation independently of its forward motion.
No,
There's two
Perspective.
vectors.
Hold on. No,
there's
there's
two
not.
vectors.
Listen,
we have to get something straight right here. My point is there's two vectors involved here, right? We have the eastward rotation of the Earth. We have the forward motion of the plane. They are not interchangeable. They are not conflatable. There is two vectors to account for. It needs to be moving some way.
Not in air travel. There's not, my friend.
Indeed,
no, there's not.
Yes,
no.
Okay.
In air travel.
I'm not getting upset.
In air travel,
of your assertion. You can even assert that it's somehow the same motion. It doesn't matter. But I'm telling you, there's two vectors.
New Perspective. I can tell you, I'm not a pilot, but I have flown with pilots, and they handed me over the control, and it is very difficult for the average Joe to keep all your gauges on target. Once you take off, you aim. Hold on, just please let me.
Go ahead.
You get your bearing. You're trying to travel the straightest line possible. Never mind my terminology, okay? But you're trying to travel the straightest line in the flattest elevation, everything for the most efficiency.
You're right about.
I know. Now, compare that to a boat. You're doing the same thing, and you're trying to stay on bearing to the straightest point A to point B, right? But the waves are crashing against you, and you're constantly making corrections against the waves. It's always blasting you all different directions. That's all GE Platypus is trying to say.
No, I get that. But see, I agree with that. I agree with everything you just said,
Yes.
and it works. That's the way the pilots fly. Now, think about it, if it had to deal with the spinning ball Earth on top of all that.
Yes. Now, that's why I brought up the boat.
Ball Earth would be a whole other factor to throw in there, because it doesn't have to account for the spinning ball whatsoever.
No, so that's the only disconnect that we have here. Then that's what I'm figuring out. What I would try and tell you, and I'm going to say it to Oblivion too, because I'm getting the feeling I'm going to get there with Oblivion quicker than I'm going to get there with you. All these things that Oblivion already knows. Hold on. All these things that Oblivion already understands that you have to try and maintain in order to fly the plane. All of those things completely dwarf the change in speed that you're going to experience due to the Coriolis effect over the course of that hours-long flight over that great distance, that you are so busy focusing on things that are far more impacting your flight that's why you don't pay attention to those things. You're
really?
already
So
in
you're
the
saying that?
process. Hold on.
Wait.
You're already in the process of keeping the plane in constant correction that you're so focused on the far more intense forces that are acting on you that are going to keep you from dropping to the ground that you don't worry about those other ones because compared to the ones you are focused on, they are negligible. And fun fact, hold on. And fun fact, and I will give you that. Hold on. I'm going to also answer your question a different way. Fun fact: if you could make a plane that flew in a straight line, okay, in a straight line, and you took off from the equator and headed north, let's say, it would obviously work south too, but fly from the equator north. If you make no course corrections of any kind, and that plane could fly straight, no atmospheric conditions interfering with you, you would start turning to the east because of the Coriolis effect.
Right. You'd be off course, right? Yeah.
Yes.
So what's this force? Now, you were talking about this force that's so negligible, you don't need to worry about it. What's the
Coriolis
force
effect.
that makes it?
The Coriolis effect.
The Coriolis force. Hold on, wait. The Coriolis force and the Coriolis effect are two different things. Coriolis effect is just the effect of seeing a curved path when actually, if you were in the reference frame of the pilot, it would be straight. But if you could be in space or if you could be on the ground looking at the path of the flight, it would seem to curve because of the rotation of the Earth.
No. It just is on. Hold on. Perspective. Hold on. Just a minor correction. I'm not. Hold on. I'm not trying to be hyper argumentative with you on this one. This is a minor correction. You're conflating the Coriolis effect with what a great circle is.
No, I'm not. I've gone over this many times with people that are more educated about the subject than you on your side of the argument. And it's not about the great circle routes that I'm conflating or confusing anything with. Talking about what the Coriolis, I have a whole thing I wrote up, right? There's a lot of notes on it for you. It's all color coded and everything. I'll put it in the chat. But the thing is the Coriolis effect is what you would see from space or from on the ground from a third party's perspective, right? You would see this curve. And that's the Coriolis effect. Is even though if you're if you're going straight line, right? You could use a star as a reference point, and you just want to go dead south, right? Like dead reckoning. Then from the pilot's perspective, he's going in a straight line, but because the Earth is spinning, it would create this illusion of a curved line. That's the Coriolis effect. There's displacement that's going on. Let's just worry about the terminology.
If you didn't make any correct, hold on. No, you're wrong. You're wrong.
You don't have it straight. That's fine.
You're wrong. Perspective. If you didn't, that's not what I'm saying.
It doesn't matter. It doesn't matter what you call it.
Because I'm talking about.
What you call it.
Hold on. You're calling it the wrong thing.
You could say that, but then explain why it's the wrong thing.
Like I said, if you made a plane that flew perfectly straight, not aiming at something, because if you try aiming at something and you stop aiming at it, you're going to correct your course to re-aim at it. I'm not talking about that. If you made a plane that could just fly perfectly straight and you set it on a course due north, it would naturally deflect to the east because of the Coriolis effect.
Yeah, we agree on that.
You wouldn't be pointing at your North Star anymore.
Hold on, wait. Okay, I'm not going to worry about the fact that you're calling it the Coriolis effect. Yes, we can call it that. I don't care if we call it that. But you would be deviated from your original intention if you try to go straight to the city you're aimed at when you take off. We agree on that.
You would
that's
be
the problem,
at that point. You would be deviated, yes. But that's me talking about an example of a plane that isn't automatically correcting its course. That's what I'm saying.
You mean a plane or a pilot? You mean the pilot's correcting your course?
No, a plane.
You said the pilot didn't have to worry about it.
I said a plane that could fly perfectly straight. I didn't say anything about a pilot.
You said the plane.
I thought we were talking about the pilot sent the
Jesus Christ!
Being that would have
perspective, dude. All I was trying to do was give you an example to help understand that yes, if you don't account for it at all in any way, shape, or form, the Coriolis effect will cause you to deviate from your true dead north path.
Well, then we agree. Then we're in perfect agreement. There's no conscious correction on the pilot's part, so he would be off course if he didn't correct for it, right?
No,
Yes.
what you're eliminating is that the pilot is in a constant state of correcting his course for shit that is far more impactful to the plane's course than this other thing that you're trying to point out.
But you do yourself a disservice by saying that, because
No,
you're
not at
saying
all.
that well, you can say not at all and hand wave it before I even make my point. Does that help you?
I think we get what you're saying. I totally do. That GE Platypus is presupposing that you would drift if that was a thing, right? And you're saying,
yeah, well, no, he's
I get
agreeing
it.
that
I
you would
totally
drift.
get it.
We agree. You would drift, right? You would have to make a conscious effort to avoid that and to correct for winds and everything else. There would be not only the winds to deal with, but the Earth's rotation to deal with. It'd be two things to deal with, not one thing that you say, oh, well, yeah, these corrections would have to be made by the plane or the jets or the conscious being. It would all have to happen, but at the same time, it wouldn't happen at all because it's so little compared to the other things that are affecting the plane. We don't even have to, it's so negligible that somehow the plane's going to be going twice as fast sideways somehow, no matter what the pilot does. It's going to happen automatically because there was other forces that were stronger to deal with. Do you realize how ridiculous that is? That's not at all a good point. It's not at all a good response. It doesn't work. It's ridiculous, and it's just wishful thinking.
No, it's exactly like people claiming Coriolis effect and shooting bullets. The Coriolis effect, alleged Coriolis effect, is so negligible it's retarded, right?
Well, it's not even a thing.
I know, but what I'm saying is it's so minute that wind, temperature, humidity, all these other effects,
all those things. Those things probably are affecting it rather than the
jet stream, everything. That's the whole point. It translates from shooting bullets directly to planes. Only planes are under control by a pilot, and they're constantly manipulating the plane, just like a boat on the ocean against waves, and they're constantly drifting,
right.
turning against waves. That's all he's saying.
Right.
But then he goes, but
that's the start of
a plane, but what he's saying is, GE Platypus is saying is that if a plane could fly perfectly straight without all this other shit, that it would drift due to Coriolis. And then, wouldn't you call that, what's that fallacy? Just assuming the consequent, or whatever. We don't have to argue about it. We're just saying the same thing, only not conceding.
What you're saying that Platypus should have conceded by now, I agree with you.
No, I hear you. It's just you're butting heads and no one's going to concede. Let's just agree to disagree.
No, but see, the thing is that this argument does take down the ball. It's not just like a toss-up, like stalemate type argument. This actually proves the proof. It is because there would have to be a gauge that he's constantly checking to make sure that his plane
is in
perfect sync with the eastward tangential velocity, and there's no getting around.
Oblivion, I just want before he continues, I just want to thank you for demonstrating your much firmer grasp on what the globe argument is here and where we're coming from.
I agree with everything he says, by the way. So there's no like his saying that it would just be like what you were saying. Like I didn't understand.
You're agreeing with it, but you're not getting there.
No, I'm agreeing that I'm agreeing that there would be.
You are the horse. We are both leading you to water, and you're just not drinking it.
You're pointing out the problem and saying, "Oh yeah, there would be deviation, and it would be so little he doesn't even have to worry about it." And you're acting like that makes sense.
Because it does.
Yeah, right? You haven't thought about it then.
I'm only saying that it's not a proof, like an actual proof, because there's so many goddamn variables when you're flying.
Well, then you haven't thought about it either, because this is a variable that would have to be perfect.
No, it's ridiculous. It's as ridiculous. Listen to me. Perspective. It's as ridiculous. The argument is perspective. The argument is as ridiculous as thinking that a person driving on a road has to account for every pebble that they drive over.
That's ridiculous.
There are far more important things. There are far more important things.
That's the most ridiculous non sequitur you could have come up with.
No, it's not.
Here, can I
Yes,
can
it
I
is.
try?
It's a false equivalency fallacy.
Can I try? Maybe I can help. So, perspective. When you, if you were flying a plane, in order to correct for the Coriolis effect, there's a particular gauge that you would look at. I would think that it would be your compass. Is that fair?
No.
Compass, altimeter, everything. It's your elevation, your direction.
Right. Well, let's forget about
everything.
the elevation and stuff because we're just worried about the Coriolis effect. So that's just going to pull you eastward. So compass is going to be the one, the big one for that particular issue. Is that fair?
Well, no. What we're talking about is the eastward tangential velocity of the runway compared to where he took off from. That's all we're talking about.
Right. What I'm saying is that if you were to travel, if you were to take off from the north from the equator and fly north, then in order to correct for the Coriolis effect, what you would do is you would be constantly checking what they call your heading, which is the direction you're traveling, which means you would look at your compass and you'd just turn it to make sure that you keep flying north, right? So you'd be turning your plane a little bit and adjusting it so that you're flying directly north. That's the gauge that you would be looking at. That's the correction you'd be making to correct for Coriolis, right?
Well, the problem is, bro, if the pilot is intentionally making the plane go twice as fast sideways, right? Which it would have.
I'm just answering my really
regardless of it,
question.
But just correcting for a course, right?
Yeah.
Right. Correcting because
I'm going somewhere.
South,
just
right?
go with me. I know. I'm going somewhere.
You're
just
leading
go with
towards
me.
the course, right? Northeast.
Just go with me. You'll. It's not a trick.
I'm
not trying to trick you.
Hold on. Wait a minute.
Okay.
I am going with you.
So,
am I going in the right direction?
My question is.
Am I going in the right direction? Southeast, right? He's correcting because of the compass.
No, you're going to be going. So the direction I want you to fly is north, right? And the Coriolis effect, if it exists, to correct for that, you would have to steer a little bit counter towards the effect of the Coriolis. So it's going to start trying to pull you east, and you're going to have to try and steer back a little bit to the west so that you're going north again, right?
But but the thing is
no buts. Just answer my question.
No. Wait, my answer is there is no deviation gauged whatsoever in the cockpit.
I know that. What I'm saying is, if assuming, and I know you don't agree with this, assuming the Coriolis effect existed, if it existed, it would try and pull you east. And in order to correct for that, you counter steer to the west so that you are going north, right?
Yeah, the pilot would say, I'm being pulled to the east because the Earth is now spinning at a different rate than I am. So now I need to correct to make sure I'm in sync. And the pilot never does that. So
right. So the pilot would have to counter steer to the west so that he's still going north. We agree on that, right?
Well, he would have to counter steer whichever direction makes him faster some way or slower in the other way.
He would have to counter steer west in order to correct for the eastward drift of the plane because of the Coriolis effect in order to stay going due north, right?
Well, the thing is that once you have
just give me this so we can move on. It's a really simple question. Come on, man. You can fight me on the tough ones.
No. Let's just say you're right. I'll just go along with you. Well, what's your point?
Okay. Thank you. Now, there's other things that also you have to correct for that are going to affect your direction, like gusts of wind, right?
Absolutely.
Okay, and you'd have to counter steer. And you'd have to counter steer. We're going to get to those too. You have to counter steer every time you hit a gust of wind that tried to blow you to the west. You'd have to counter steer a little bit east, right?
Yeah, you'd have to correct for that. Correct.
Right, and you'd have to trim the plane like the other person. I'm not looking at my screen right now, so I don't know who it was. But the other person was talking about you have to trim the plane. To make sure that, and you have to go up, you have to go around the mountain, you have to do all these things, and you have to be thinking about all of them, and they all have to do with the direction your plane is flying, right? So there's a lot of different little things. Is that fair?
Agree that and you agree the pilot could just fly wherever he wants to, he doesn't have to stay on course, right?
Well, the pilot can fly wherever he wants to, but if he wants to go due north, then he can't do whatever he wants to, because what he wants
but
is to go due north.
let's say he wants to
No, but we're
travel
not saying
1,000 miles
any of
east
those
and
things.
1,000 miles west, and then
No,
finally get to his
no.
destination eventually.
No, we don't want to know, because that's confusing. You're
Oh, that's a
confused.
problem.
Yeah, because
The
what I
problem is,
want to
bro.
do is because no. The problem is I'm trying to explain a really
Okay,
straightforward
I'll
concept.
let you get to it.
Oh, thank you so much. Okay, so he's flying. So he's flying due north, and gusts of wind are coming from the left and the right, and those are happening often because you're flying through the air. Is that fair?
Mm-hmm. Sure.
Okay, so you're constantly correcting for those, right?
Mm-hmm. Yep.
Okay, and the corrections that you're going to be making for those are going to be, you're going to be looking at the same gauge, your compass, right? And so you're going to be making those corrections on your plane's direction in order to hold that heading, right?
Yep.
Okay, and if that were the case, and all of those corrections were significant, and there was also, in addition to those, like a drop of, a touch of Coriolis, if it existed and you were a pilot, is it reasonable to imagine that you might not notice that you're also correcting for Coriolis as you correct for all those other things, because the thing that you're doing to correct for all those other things is factoring the Coriolis into it?
No, it's
Is
not
that
reasonable,
possible?
but let me tell you why
That's
it's not
not
reasonable.
reasonable? Okay,
Nope.
tell me why. Now we're getting
Okay.
somewhere. Tell me why.
Yeah. Because now let's just take it to the very end, right? Let's just say that
Mm-hmm.
that pilot now has subtracted the correct amount that he would need to if he was coming from the equator and headed north, like you're talking about, right?
Sorry,
Now,
hang
it
on.
was going
The pilot's not doing any kind of calculations. All he's doing is holding the plane north.
right, but
Right?
let's just
And
say
so he's holding the
somehow,
plane north
regardless,
against whatever effects, whether they be
right?
Coriolis or gusts of
Okay,
wind or trim, or it doesn't matter what they are. He doesn't
I
do those
agree. Right,
calculations. All he
that's
does
fine.
is put the nose back to north, right?
Right. Okay.
So
Now,
he's not going
let
to
me
know that it's
now.
Coriolis. Does
I
that make
understand
sense?
exactly.
Just
Yeah.
before you
No,
respond,
no,
does
wait,
that make sense?
Yeah, and let me just say that
Okay,
that makes sense, and
that's
you're
all I
making
want.
my point. You're making my point, though.
Great.
And let me
I'm
tell you
glad I'm
why.
helping.
Okay, you're telling me that because he's on course, right? He's going to be in sync with the Earth because of him being on course, which is what I was trying to say when we first started this by saying it's on course and using a north-south declination, or just using a compass is going to help him stay on course. And regardless of the winds, if he's on course, then he's going to be in sync with the Earth when he's trying to land on a runway that's now twice as slow, let's say, right? Because he's coming from the equator, right? So you're saying that because he's staying on course, the 1,000 miles an hour conserved momentum that it had when it took off because it was on the Earth where it was 1,000 miles an hour. Now it needs to be exactly in sync with a 500-mile-an-hour runway when it lands, right? And because he stayed on course, let's just say that whatever it was that he did, the corrections for the winds and all these corrections by using a compass, somehow also added on the extra bonus that it slowed the plane down.
That's right.
In its eastward tangential velocity, right? So that now
Right.
the plane, regardless of the pilot even noticing, is now going twice as slow as it did when it took off, right? Eastward.
Right.
Can you agree with me that that's a separate vector from the
A
plane's
separate
forward
vector?
motion?
I'm not sure that I don't know whether I agree with that language, but I do agree with you that, like, when he takes off, because of the rotation of the Earth, he's going to tend to bend to the east, and when he corrects to the west, if you want to think of it as that correction to the west being like a bleeding of velocity, I'm not sure whether that is, like, I'm not a physicist, I'm not sure whether that makes sense, but, like, if that's how you want to understand it, then I don't have a problem with you thinking of it that way. I'm not going to necessarily accept that corresponds to reality, but if that helps you, then I'm fine with that.
Well, it's not about helping me understand.
Somebody better at
You know what? Wait, we don't need to.
distance than
Wait.
me.
Hold on.
Yeah.
We don't even need to refer to the professionals about this one, bro. We can go through it
Sure.
step by step. Okay.
Yeah.
And
You wanna
don't
think of it
pretend.
as-
And
you
don't.
wanna
And
think of it as the
stop.
correction.
Could you do
back
me
to
a
north
favor
being
and
a bleeding?
stop?
That's okay.
Could you stop? I like that you're going through this and you're actually understanding it to a certain degree and accepting that maybe there's something you don't understand about it. But don't assume that I must not be understanding something for just a moment, right?
Let's both
Because I do
assume that we
understand
both
things.
could not be understand. Well, let's both assume that we both may not understand some things. Can we do that?
Well, of course, we can always do that.
Okay.
Let's just go
let's do
through
it
the
that way.
actual common
Let's
sense
do it
of the
that way.
whole thing, though.
Go ahead.
Let's go through the common sense of the whole thing, right? And when I started this argument earlier, I talked about a helicopter going straight up in the air when it was at a certain latitude, so it retained the conserved momentum. Let's just say it was a hot air balloon, right? Now the hot air balloon has like little things like on it, so it can kind of like give little bursts of motion, like left or right, or forward or backward or whatever. Right?
Now it's just a dirigible.
Yeah.
Well, now it's
so
a
let's
blimp.
just say like the hot air balloon. Let's just say the hot air balloon goes straight up in the air, right? Now,
sure, it's a blimp.
A flat earther might make the argument that, like, oh, well, why isn't the Earth spinning below the hot air balloon automatically when it goes up in the air? Well, the argument is that it retained the conserved momentum from being on the ground, correct?
Well, that's part of it, and then part of it is that it's getting blown around by the wind, and the blowing around of the wind is probably going to have more of an effect on it than the fact that it's not, touching the earth anymore.
Sure, but you're not. Okay, right. Yeah, so the wind's going to blow it in whichever direction.
Yeah, it's not going to go straight up. It's going to go all over the place.
Well, yeah, let me make my point, though, is that the ball Earth argument is that the reason that the Earth isn't spinning automatically underneath the hot air balloon is because the hot air balloon retained the conserved momentum from being on the Earth when it was spinning at that speed. Can we agree on that?
If there was no atmosphere, you mean?
Regardless of the atmosphere, the claim is
it would start to. There would be Coriolis effect. There'd be Coriolis effect.
Well, no, of course there would. Of course there would. I'm not trying to say that there wouldn't be or would be anything.
Yeah.
I'm saying that the initial let's just say there's no atmosphere. Let's just say there's no atmosphere affecting it for the sake of getting to the next step, right?
Sure.
It goes up in the air, and the reason it's moving with the Earth is because it was on the Earth, right?
It initially, yeah, but it's not going to stay.
Okay, you don't have to say but. Just like I gave you the consideration when you went through your scenario. I let you go through it. Okay, let me do the same.
Yeah, okay.
Right?
So
we agree on the fact that
what are you trying to say? So
initially, sure. I'm getting to it if you let me say it and walk through the steps like I let you do.
Yeah.
Okay.
Go ahead.
So because the hot air balloon was on the Earth, it retained the conserved momentum of the motion it was already going with the eastward tangential velocity of the Earth with. That is the ball Earth claim. Yes or no?
It does retain energy, so yes.
It retained the eastward tangential velocity of the motion of the Earth from being on the Earth. That is the ball Earth claim. Yes or no?
Yeah. Yes.
Yes. Right. Okay.
Mm-hmm.
Now you mentioned that winds can blow it in whatever direction, right?
Mm-hmm.
Right. Now, are you also thinking that the air, regardless of the winds, is carrying the hot air balloon along with the rotation of the Earth?
I mean, the air is going to. Are you thinking that the air is not going to be static? Like the air is moving around?
No, I'm asking if you think that the air is moving it along with the Earth.
Sometimes, and sometimes it's moving it in like lots of different directions. Air kind of moves in lots of. It doesn't necessarily move in necessarily the eastward direction.
We agree. Great.
Lots of
directions. Agree on that. The air is a wind. The air isn't separate from the winds, right? The only thing that moves the hot air balloon is a wind.
Concepts.
Correct?
The only thing that moves the hot air balloon is the wind?
Unless it propels itself.
Yeah, well, I mean, and also can go up. Like, they're not exactly, but I don't want to nitpick.
I mean, not exactly.
Like,
what do you mean, not exactly?
So it's going to go up and down, and that's not going to be dependent on the wind. That's going to be dependent on buoyancy. But I think that.
Okay, sure. I agree with that. You can say that. You can add that. But we're just agreeing that the air isn't moving it. The air isn't moving it to stay in sync with the Earth, right?
Well, the air is going to move it, and it's going to affect it more. It's going to screw everything up. It's just going to make it so you can't even tell, right?
Right. Well, you would be able to tell, though, right? Because if
No,
it's
you
not
wouldn't
in
be able
sync
to
with
tell
the Earth,
anything.
well, the thing is
It's
that
never going to be in sync with the Earth.
listen, well, it would have to be.
No, it won't. It'll the air, the movement of the air, the wind is going to have such a massive effect that, like, if you've ever released a balloon, it never goes straight up. Never.
Well, that's the thing is, listen, bro. Now, if the hot air balloon pilot, or whatever you call that guy, decides to go straight back down, right, after the air has pushed it all these different directions and it's no longer in sync, like you just said, it would never be in sync, right?
Yeah.
So now
It's gonna blow it all
the
over the
hot air
place.
balloon is going to land on a moving surface, right?
I mean, sure, yeah, I guess, considering
Yeah,
that
well,
the
that's going
world
to
is
be a
spinning.
problem.
Yeah.
No,
Why?
because hot air balloons go up and they come back down, and they don't have to worry about the ground moving separately from the basket. It's just stationary relative to the fucking to the balloon. No matter
have you been
no
on a hot
matter
air
which.
It is
What do you mean? Have I been on a hot air
balloon?
balloon? Why does that matter?
Well, like, I mean, if you've ever watched a hot air balloon try and land, it is like trying to land on a moving target. You're moving. I mean, whether you think the Earth's moving or you think you're moving, either way.
Oh, you
there's a
think
lot of
there's no
lateral.
difference? Wait, hold on. Do you think there's no difference?
In terms of, like, I mean, when have you ever like been on a train and, like, the car next to you, the train next to you, like, starts moving, and for a second you think that you're moving?
Sure.
Yeah. It's like, I mean, if you
That
were
doesn't help you. That doesn't help you, dude.
You know what
Listen,
I'm talking about.
I
You want to
do,
talk about
but I'm
relativity?
saying
We
that
can talk about relativity.
no. Wait, listen.
It's a different subject.
These are the things that they use to confuse us, right? They say it doesn't matter if you're spinning because you could go all these different directions at different speeds, and you don't feel it on a one linear direction of an airplane. So just because you don't feel it on an airplane, you could be moving in several different directions and not feel it. Or, you know what? It doesn't really move 1,000 miles an hour, because if it were as small as this clock over here, then it would be moving twice as slow as the hour hand, right? But if that clock were as big as the Earth, they say the Earth is, right? Then that tip of the hour hand would be moving literally at 1,000 miles an hour. These are little tricks that the ball Earth proponents use to make you think there's no problem. Now let me get back to the helicopter and
go back to the helicopter.
Listen, go back to the airplane or the helicopter. That
sure, I mean, a glass of water on an airplane and throw a ball up and up and down and catch it in an airplane.
Those are things that are just like small examples that they then decide could be just, scaled to whatever degree and adding motions and directions.
Why is it different?
Wouldn't even matter.
I can throw a ball in a moving car and it doesn't feel like we're moving, but we are. Right? When I throw a ball straight
and that's
down
another
in a
straw
car.
man. Yeah, these are straw man.
Why? Why is that a straw man? It's exactly the same idea.
No, it's not. You're confident that it is the way you say that. But I can tell you why it's not.
And the plane is going 100 miles, and the plane is going 1,000 miles an hour, it's going to do the same thing. Why is it different in a plane at 1,000 miles an hour, but it's different on the Earth at 1,000 miles an hour?
Do you want to recite it again with more confidence? Because I heard you the first time.
Sure. Okay. So, like, if you're in a plane, and the plane, I don't know, planes, you can't do a commercial jet with a plane going 1,000 miles an hour, but, like, say 750 kilometers an hour, right? You get a plane, you're throwing a ball up in the air and catching it at 750 kilometers an hour. You can't tell that the plane's moving at 750 kilometers an hour.
Yeah,
so why would it make a difference when you travel on the Earth and at a rate that changes the distance, 750 kilometers an hour? You're not going to be able to tell. Right.
Okay, so I'll let you restate it, and that's a little bit more specific in what you're trying to say. So I agree that is the case. And my first point to you was that these examples are what makes you feel like you've got a point that just you can just go on the rest of your life and think that solves it. But I can tell you right now why it doesn't. Are you ready to listen?
Yeah. I'm begging you to tell me why it's a straw man.
Okay, great. Well, because if you're going to throw that ball, let's say the ball is a plane, right? Let's use the drone on a plane, which sometimes
No, we're going to use a
using a better
ball on
one.
a plane. That's the straw man. You say you want me to tell me why that's a straw man.
No. It's not a straw man in that doesn't happen. I'm not saying that
That's
to
what you
conserve
told me,
momentum.
is that you said it was a straw man because the
It's a
plane is
straw man
different
for
than
the
the Earth.
argument. But no, listen. The reason I'm calling it a straw man is because we're talking about the hot air balloon or the helicopter or a plane that's lifting off the Earth and then going to a different tangential velocity where it needs to be either twice as fast or twice as slow or a little bit faster or a little bit slower when it lands, right? And you don't
Right.
have a gradient. You don't have a gradient of tangential velocities on a plane that you're throwing the ball to or catching it from. There's a difference in tangential velocities that the plane in one complete enclosed cabin doesn't account for. It's a totally non sequitur. That's why it's astronomy, because it's not the same.
Okay. Have you ever been on? Have you ever been on like one of those like things that spin you really fast and it sucks you to the outer wall?
Absolutely.
Like a carnival ride. You know what I'm talking about?
Yeah.
Have they ever let you like throw a ball to people across the thing?
Yeah, you can't do it.
And the ball, once you throw it, right, it's got the same forward velocity, like it's got your velocity around the circle, right? And then once you throw
it goes off track. You can't do it.
It goes off track. But what's happening is that it is the reason it's changing direction is because it's quote unquote losing that tangential velocity, right?
There you go.
And so like that tangential velocity that you're saying is low, you're like, where is it going? It's going east. That's where it's going. So when you travel north from the equator and you bend to the east, that is your like that's your extra tangential velocity. That's what's bending you east.
No, okay, wait. Listen, you're no. Like, I understand this a little bit better than you. Just to be honest.
Well, that doesn't
just to
seem
be frank.
correct. That doesn't seem to be the case in this case now, does it?
Well, because you just said that it would bend to the east, but actually, if you're going from the north to the equator, right? If it was a ball, it would actually bend you to the west. It would bend you the opposite
well,
direction.
whatever. I mean, I don't.
Well, that's
doesn't
important.
matter.
No, it does
not
matter.
important to the
Wait, hold
argument.
on.
Does it
Wait,
matter?
wait,
Then I
hold on, wait.
stand corrected.
Wait a
Then I
minute.
stand
It does
corrected.
matter.
I don't care.
You know why it matters? You know why it matters? Because it
No.
actually would make you deviate the opposite direction of what you would need to be going faster towards.
Right.
Because if you're going from a 500 mile per hour
deviates.
latitude to, but that's not the argument. It would deviate if it was a ball.
It would deviate
Yeah, we
if it's a
agree on
ball,
that.
and it does.
Yeah,
And it does.
I'm not saying it wouldn't. I'm not saying it wouldn't. You're acting like I'm saying that the Coriolis effect wouldn't be a thing. I'm not saying
Do you agree that the Coriolis effect does actually affect the direction of things that travel north, and that they do bend to the east or west or whatever?
If we were on a spin, that's my point, bro. If
No,
we were on a
I'm not saying
ball,
if we're on a spinning
would.
ball. I'm saying that it happens. It happens on this thing that we are on. That
as
things
far as
bend.
physics go, it would happen with this thing.
No, I'm
we're
not
on,
saying that.
If it were
my
a
question is
spinning
a
ball
simpler
that we're
one.
on.
No, I'm not asking you hypothetically.
You need to slow down. You need to slow down and listen to me, bro.
I'm trying to.
I'm agreeing.
I'm trying to.
I'm not disagreeing that the Coriolis effect wouldn't be a thing if we were on a spinning ball. We agree on that. But you don't have a Coriolis
not what I'm
effect.
asking you.
You don't have a Coriolis effect to deal with when you're throwing a ball to yourself on the plane, do you?
When you're throwing a ball straight up and down on a plane? I don't think so, no.
Oh,
no,
but then why did you say that there would be a Coriolis effect if you're talking about the hot air balloon? You said there would be a Coriolis effect with a hot air balloon going off the Earth.
If it's traveling north-south, if it's traveling north-south, there would be. Because because there's an Earth spinning.
Then we're agreeing. We're agreeing. Well, because we agree that there would be a Coriolis effect?
There would be.
Are you saying that the pilot, but you're saying the pilot doesn't have to worry about the Coriolis effect?
Well, what I'm saying is that the pilot, because he's dealing with the corrections that result from all these other things, He doesn't know where they're coming from. He only knows that they are affecting him. So he is just correcting his course. And so the reason he doesn't notice the Coriolis effect is because it's a drop in a bucket. It's a
Okay.
it's a push on a shove. It's a small amount
listen to me.
that is affecting the same things as the larger amounts. You understand that, right? You understand that point? You can make your point. You can make your point in a second. Just please tell me you understand that. Thank you.
I understand that, and that's my point. Is that doesn't work, bro? You can't just say that because it's so much less than all these other things you would have to deal with. That because he's on course, he automatically is going twice as fast sideways without the pilot having any idea that that's happening. That's ridiculous. It's another little trick that they get you to just repeat with confidence, as if you're making a point that I don't agree with.
You're not making sense.
And that I'm not understanding.
Exactly.
I think we beat this one to death. This one to death. I tried. I mean,
no. Wait, hold on. You're going to run away from me now. Oh, wait, hold on. You're going to run away now?
Don't run.
You're running away. Right as soon as I'm about to make my point.
What do you want to talk about then? You want to ask me?
Because you're just going to stand with confidence as if you had a point that I didn't understand. I get this way more than you do, bro. You don't even get what I'm trying to say.
I do,
Listen
but it's
to the
nonsense.
Scenario. Listen, I'm going to walk you through it. Right?
We'll try it again. Go ahead.
One more time.
Right? And you're going to just walk me through this.
Again.
I'm sure you don't want this platypus because you didn't have an answer either.
No, this is Oblivion. Twice the distance over time. Twice the distance over time. That means every minute. Listen, you've been talking for hours. That means twice the distance over time. That means every minute it's less.
Yeah, I'm here. Everything's cool.
Tell these guys that I need to go through the scenario, and Oblivion doesn't understand what I'm trying to get at, and he thinks he does.
Oh my God, we've been hearing this shit for a long time, dude.
It's all. But don't give up now, Oblivion. We're just getting to the good stuff, bro. We're just getting to the good stuff.
The longer the distance, the less deviation over time, man. We understand.
No, the more deviation over time.
No, the longer the distance, the less deviation over time.
What are you talking about?
What are you
talking about? All right. If it's twice the distance over 1,000 miles, it would be
2,000 miles.
It would be less deviation over the same deviation over half the distance.
But they don't teach you any of this shit. That's the problem, bro. They don't teach
help,
you
dude.
any of this stuff.
Talking about less or more deviation doesn't even help, Oblivion. You're not helping. Please stop.
Oh my God, you don't get it.
Dude,
if I had an 8-mile trek over water, I'm going to have a hell of a lot more deviation than a 16-mile.
It doesn't matter about more or less. Trip. That's not the point.
Oh my
Let me go through this, please. I'm going to try one more time. Wait, hold on. Wait, we just had a guy come in here, act like he knows what he's talking about, say things that I already agreed with, and then act like he had a point and he tried to explain it to me as if I didn't understand.
Exactly.
And now he wants to walk away as if I didn't get something.
Recorded, man. By the way.
Right. And let me go back through that with the guy that thought he knew everything. He doesn't want to learn anything new. Who is that guy?
It's probably me, but I mean,
let me
what
just
is new? Tell me new things. Tell me
at this point, don't call him new. Don't call him new. Call him Neo. Because Mr. Anderson, he's whooping your ass.
All right, Neo.
Humor, man.
Mr. Anderson is whooping whose ass?
I'm saying call you Neo perspective because you're whooping his ass.
Perspective, bro.
Okay, that's what I want.
No, you're getting wrecked.
Neo, I'm being Neo whooping your ass right now. Did you hear that?
You know what? You want? Go ahead. You want to try again? You want to try again? Go ahead.
I want to try to. I want to try to.
Yeah, try and educate me. Go ahead.
I'm hoping you're open-minded enough to understand the problem.
I'm open-minded. I'm just not seeing the problem.
You're not even trying yet.
Open mind but closed eye.
I'm trying. I'm being very patient with you.
Okay, let me start with the scenario that the pilot is on the plane. It's taking off from a 500 mile per hour latitude, so it has to conserve momentum of 500 mile per hour eastward tangential velocity, moving in sync with the Earth when it
Stop.
takes off.
Go back.
You already lost him.
You've already, you want to go slow and try and explain this to me like I'm 5, and explain it to me like I'm 5.
Really? I thought you had that much.
I think I do, but I don't think you do. So let's go slow together.
Wait, can you just at least stop assuming that I must be confused on this issue for just this scenario? Just walk through with me.
Yeah,
Like I
let's
gave
both
you
let's both
same
assume
thing.
that not. Let's both assume that let's just go slow together. Okay.
Okay, so then the reason that the plane is moving eastward with the tangential velocity of the Earth when it takes off is because it was on the Earth moving with the rotation at 500 miles an hour when it ascended.
Right.
Can
Right.
we
So it's
agree
going
on that?
500 miles an hour eastward, and it's taking
Right.
off in an eastward direction.
No, it's going south.
It's going south. Okay.
Right.
So it's got
So now,
500 miles an hour eastward direction, and how fast is it going southward?
let's just say it's going 400 miles an hour southward.
Let's
Right.
just say
So
it's
there's
going
two.
500 miles
Yeah.
an hour southward to
So
make it even
let's
numbers.
establish
It's the
that.
same.
No. It's better. It's different because there's two vectors we're talking about.
All right. Fine.
It's going
Whatever
with
you
the
want.
Earth.
What if it's going?
Wait, stop it. Just put the attitude aside for a minute, bro, and we can finish this off so other people don't get aggravated listening.
That wasn't me.
You
That
act
wasn't
like
me
I don't.
talking.
Yeah, you said
That wasn't me
fine,
that
whatever
time.
you want.
That was me, bro. My bad. My bad, Dave.
Okay. I didn't think you said that. Anyway, regardless, if it's going in two different vectors, it's going eastward regardless of the pilot's awareness of that. It was just going with the Earth when it took off. So it's going 500 miles per hour automatically eastward, as well as going like 200 to 300 to 400 as it accelerates south.
Pick a number.